Welcome back. So in this example, we're going to look at the integral of x times e to the y over the curve c, which goes from the point 2, 0 to the point 5, 4. This is example 4 in your book, and let's get right into it. Okay? So the first issue, really, the most difficult thing, because really we don't want to repeat the same sort of problem a billion times, right? So if we knew what the curve was, we would basically be done. We could just watch the previous video and do it. So the question really is, what is this curve? So well, notice we're not given a value t. There's no t mentioned. So you have to come up with the t. Yeah, I know you kids like to talk about, what's the t, give me the t, share the t. In this case, you have to come up with the t. Okay. So 1, 2, that's the point, this is the point 2, 0, and 1, 2, 3, 4, 5. Okay, so these are our 2 points, 2, 0, and 5, 4, and we are going to connect them with a line. And of course, I got my points backwards. This should be let's see, 5 and 4. So it should be a little lower, right there. Okay, 5, 4. Okay, so all we got to do is find the curve that connects these 2 points. So this is going to be y equals mx, right? Mx plus b, where m is 4 minus 0, 5 minus 2, so this is 4 over 3. And then we can just put in some value. I like 2, 0 because 0 is nice. So if I plug in these values, I get 0 equals 4 thirds times 2, right? That's the 2 here, plus b, right? And I'm going to subtract that to the other side. So I get negative 8 over 3 equals b. Okay, so my curve C is y equals 4 thirds, right? That's my m, x minus 8 over 3b. Okay? Well, let's think about that. There's still no t, but there's a y and there's an x. So what could you do? Okay, yeah. What if I said let x of t equal t, right? And now y of t, this is going to equal 4 thirds, not x, but t. Okay? Now, I do want to say this. By making x equals t, I'm going to have fractions here. Now, if I were to introduce some other values, maybe x of t equals 3t, okay? If I sort of arbitrarily make it like that, or I say x equals 3t, then I'll get some cancellation. I'll do that in a second, but for now, let's do this the natural way. the least thinking method is how I've done it on the board right now. So let's do that. Okay. So I'm going to integrate this. Well, where is t varying, right? Because I have this a t to b, okay? Well, what is a and b? Well, t is x, so where does x vary from? It varies from 2 to 5, okay? So t goes, because x goes from 2 to 5, t goes from 2 to 5, okay? So that's 5, this is 2, plug in x, I get t, and then I go e to the 4/3 t minus 8/3 d square root, and then I'm going to take the derivative of this and square it, so that's 1 plus derivative of this with respect to t is 4/3, and I square that. Okay, dt. This is just a number. Okay, so I can pull this out. Okay, and then this right here, I can do this, right? This is just integration by parts, right? So let me rewrite this. This is the integral 1 plus 16/9 on the front, integral 2 to 5, e to the minus 8/3 times t, e to the 4/3 t, right? So basically this e to the negative 8/3, it was right here, and by the property of exponentials, I can split that up, right? So I split it up, and then I can pull that outside, and that allows me to just ignore it, okay? So ultimately, all I'm doing is integrating t times e to the 4/3 t power. This is very, very simple, okay? But I'm not going to do it. This is a little messy. So I want to make it less messy. But you could do it in principle. Well, let's make it less messy. So I'm going to write down here, we have this curve, y of x equals 4/3 x minus 8/3. Well, let's come up with a better parameterization. What about x of t equals 3? Well, I want to plug in for x. I want to say that when I plug in x, I want the 3 to cancel, so I just have a t. What if I put a 3 in there so the 3's cancel? That seems pretty obvious. So why not have 3t? X of t equals 3t. Okay, so now when I plug in y, what do I get? I get 4/3 3t minus 8/3, and these 3's are going to cancel, and I get 4t minus 8/3. Okay, so it's a little better, and I can summarize this by saying this is 4t minus 8/3, and t is going to vary. See, this is the problem. Now I have to solve for t. So t is now 1/3 x, and x is still going to go from 2 to 5. So if x is going from 2 to 5, t is going from 2/3 t to 5/3. Okay? And then when I plug this in, I get 2/3, 5/3, the 3t, e to the 4t. And I'm going to go ahead and pull out the e to the minus 8/3. Okay? And then we're going to do the second part. So when I take the derivative of x with respect to t, I get a 3, and then I square it, so I get a 9. And then I'm going to do the same again with y, so I get a 4, and then I square that, I get 16 dt. This right here is what? 15. So I'm going to pull out the square root of 15 times e to the negative 8/3, and then 2/3 to 5/3, 3t e to the 4t. Well, I can again pull the 3 out. And this right here I do by parts. Okay? So not very fun. I don't want to do it. This isn't a Cal 2 course, but that's basically it. I kind of drew this example on a little long, and it's really not that difficult, but hopefully that was clear. You should be able to do it in principle. Okay?